Hello and welcome everyone to our Kafka live stream. Thank you all for joining. I'm your host, Adam Noonan, and we've got a guest today, recurring member, Ivan, who'll be helping out. Hey, Ivan, how's it going?
Wait, until I figure out how to unmute myself. Hello, everyone. How are you? How are you? Hope you're all doing fine.
Doing well. Definitely ready for the weekend. I'm sure I'm not the only one. Ivan, you're back in Croatia, right?
Yes, yes, yeah. Hope I thought maybe it's gonna be good weather, but as I was in Madrid, where is nice weather, I'm a little bit jelly on you. But I returned back to a handful of rain. Kind of remind me back to the days when I was in Belgium, when I was living in Belgium. Yeah.
Yeah, good old days. Lots of
Good
rain.
old, good old days.
Yeah, we've got the very first Madrid professional American football game this Saturday. So I'm proud to be going to that.
Oh,
But
nice.
for today and right now, we'll be talking for the next 30 minutes about key partitioning strategies in Kafka. Does that sound good to you, Yvonne?
Well, I suppose so. Let's try.
Perfect. We'll give it a shot. As always, if you have any questions, comments, corrections, feel free to chime in on the chat. If you're tuning in on YouTube, you can always join our Zoom chat as well. Active audience member there. But today we're talking about the Kafka key strategies. And what do we really mean by strategies and using keys? Well, first, we should probably define the key. So when we're talking about the structure of a Kafka messages, there's three core parts really that usually come up. One is the key variable, which we'll be mostly focusing on today. Then you have the actual message content, so the value there. So when you're talking about a data field, that's almost always in the value. That's going to be your core payload. And then Kafka always has metadata about a Kafka message as well. So that includes offset, partition, and timestamp. And key, what we're really going to be focusing on here is that key is used to determine which topic partition the message will be stored in. So if you think about sharding data out and partitioning data, usually for balancing load, that's exactly what Kafka does. Based on that key value, it will then assign a specific Kafka partition for that message. And that selection process happens through a hash, which we'll define in just a moment. Something important to know too is that is a really simple key example. It's a string value, but you can get very complicated with keys. You can have a full object used as this key value. And best practices when we're doing that is to back that schema, that object key by a schema so that there's ever a change, you can track that change and make sure it's compatible either forwards or backwards there. And it's important to note that, again, Kafka is going to be hashing this value to determine where it's going. So any value with the exact same key is going to go to that exact same partition. And that's exactly how we determine ordering. So in summary, your key is always going to result in your partition assignment. So when you're determining what value to select as your key, it's important to know the impact it's going to have on event ordering and load distribution, usually in that order. There's a couple other parts of the Kafka ecosystem with streaming capabilities, joins and aggregations, as well as your ability to create a log compacted table and derive state. But the two key things that we want to always keep in mind with our key values is event ordering and load distribution. And to give you a quick kind of visual explainer for everything I demonstrated, Vaughn, can you see the Excalidraw that I now have up? Or is it
Yeah.
still? Oh, it's
Yep.
perfect.
Yep. I can see.
Thank you. So for this example, we've got two messages here. Message one with customer colon 3289 for our key value. And the second message is using customer colon 8504 for our value. So because these key values are different, very similar, but they are different, they're going to be hashed differently. And based on that hash, assigned to different partitions. Now, within that partition, ordering is guaranteed. So for every message that contains the exact same key value, we know they're going to be written in sequential order. But for messages that have a different key value, such as this message, it might be written to a different partition, and we can't ensure ordering across multiple partitions. So that ties into what we mean when we say ensuring ordering. And it's important to note that this isn't just for a producer writing to Kafka. This also impacts consumer groups as well. Since if you have sort of a hotspot, which we'll define in a moment, that's going to limit the amount of throughput that you're able to get out of your Kafka topic. So hopefully that visual explainer was solid too. Some of the definitions that we'll be talking about today are hotspot partitioning, or a hotspot specifically. And this is referring to when the load is unequally distributed across all available partitions. So if we have 9 available partitions and we're writing a lot of messages with the exact same key value, that's probably going to result in a hotspot where that producer is writing way more frequently to one specific partition, and that consumer group is then having to read from that one expanded partition more than the rest. So we're losing throughput capabilities there. Something else that I mentioned was log compacted topic. So this is getting a little bit technical, but it's a stateful store in Kafka. This is also heavily dependent on the key, since we, instead of a full stream of events, we actually have more tabular data. So essentially a table. And you write to this log compacted topic based on the key variable. And if you write with that same key, you're going to overwrite that previous entry. So we'll more on that in a moment. And then the term round robin we'll be using today. Round robin just means distributing messages in a uniform pattern in a sequential order. So one partition, then the next, then the next, then the next, ensuring that load is evenly distributed. And this is exactly what Kafka uses when you don't include a key variable. So you can send a message with just value data, value information. And when you don't assign a key, Kafka is just going to write that message in a round robin fashion. Partition 0, 1, 2, 3. And so on until it hits the end of that list, starts back over. So you know for a fact your load is going to be evenly balanced, but you lose the capability of ordering within Kafka as well. So for use cases where ordering is not incredibly important, this is a fantastic way to go. And then hashing. What do we mean when we say hash? So a hash is an algorithm that takes an input value, and it always returns a string of uniform length that can be used to derive and get back to that input value. So here we're taking 2 inputs, topic names, New York Yellow Taxi trip, that's going to have an output of uniform length. And then any variable we provide is always going to have a hashed output of that exact same length. Even if it's a full 500-page essay, it's still going to have a hash that exact same length. And Kafka uses that hash to assign those partitions. That's why it came. And rethink. So when we're developers and we're working through partitioning and what keys we assign, it's really important to keep in mind when we're starting from day one, what our partitioning strategy is and what value we're using for our key. Because getting this wrong can skew data, can cause data skewness, which means encountering hotspots, overloading a single partition, and not distributing load efficiently. And this is going to impact downstream performance and reliability, not just of the topics, but of the brokers as well. Since each partition has a leader on one specific broker, if you're really overloading a specific partition and doing too much of these hot spotting configurations, you can easily overload a single broker there. So great information in theory, all great to know when we're as developers, but how can we practically extrapolate some sort of decision matrix? So what's the thought process we should probably have when I'm trying to decide how to key my data? First question, I think, should be ordering. So does ordering matter at all? Does the order of the event log as we're writing to Kafka, does it have an impact on downstream applications? Do we need to ensure ordering globally, meaning that every message written to Kafka needs to be sequential so that we can derive state? And if that's the case, then there's a second question to ask. Is throughput critical? Because if it's not critical, maybe it's a very low throughput use case. Maybe a single partition is actually okay for this. Typically not advised. And depending on your topic creation rules, might not even be possible. But if you do use one single partition, you know for a fact every message written to it is going to be globally ordered in the order that it was written, that partition. If throughput is critical, then you're going to have to get a little bit creative. One solution we came up with is adding an ordering ID to the actual Kafka message so that downstream later on, you can derive some sort of order. But if you're using more than a single partition, you can't be guaranteed of order in Kafka itself. Usually though, ordering matters at a subset, so a subset of data. So if we're talking about taxi trip data, we might use a vehicle ID as our key value. And what that's going to ensure is that ordering is always the same for each vehicle. Since a vehicle ID is always going to be written to that same partition, we know that vehicles, one single vehicle will always write to that same partition in the order that those events happened. So you use a single key value depending on where ordering matters in multiple partitions. If ordering doesn't matter at all, again, totally fine to not use a key value, and Kafka will automatically partition data in a round robin fashion to evenly distribute load.
Yeah, I want to here just add a little bit of something that in case you really want to go in the path of creating a single partition topic, think not twice, not triple, but quadruple, because your Kafka admins are really going to hate you. And you most likely don't want to cause any frictions. Usually single partition topics are misuse of Kafka itself. Sometimes it's maybe needed, but really think whether you want to do that or not. Yeah, just a note.
I'm glad you mentioned that too, because that's the second or third time somebody's mentioned that relationship between operations and developers, specifically on this subject, where developers are determining what to key their data by. Because if a developer isn't aware of how their key affects things in Kafka, that can often result in a ticket to operations to say, why is my throughput so low? And then operations obviously responds, hey, that's your fault. You keyed this incorrect.
Yeah.
Perfect. Thank you. So after you've decided what your requirements are for ordering, your next question should be, how is this load going to be distributed in Kafka? So we've decided vehicle ID is how we need things to be ordered. The next question you should ask, does that put us at risk for hotspotting? Is there potentially, a specific taxi that has an insanely large amount of taxi trips compared to the rest of the taxis in our data set? What's the variability here? And if the answer is yes, we do have one specific or a set of specific key values that have much more high occurrence than the rest, then that might be a sign for us to use a composite key to actually order these, to partition our data, which will affect ordering. And a composite key is essentially using that vehicle ID, but then combining it with another value within our Kafka message to use that as our key value and affect ordering. And if no risk of hotspot, vehicles are pretty much evenly distributed, totally fine to keep that current key strategy. So the two main questions we want to ask when we are deciding our key is, one, where do we need ordering? And two, is that an equally load balanced workload? Missing anything there, Ivan? Nice. Thumbs up. The next questions you should ask, which usually come after, would be depending on what you want to do with the data once it's in Kafka. So if we're planning to easily enable stream processing, something to keep in mind that when we're doing joins and joining two separate tables, simple string keys are really easy to use and really enable these joins in a better way. So it's much easier to join topics when the keys are easier than simple string values. We're not planning on doing any joins or windowed aggregations. Complex object type keys are totally acceptable. These can be Avro, JSON. Again, when we're working with complex giant object keys, ideally they're backed by a schema so that any changes there are recorded. We can always revert back to a previous version. And we also know that we're changing things in a compatible way as far as that evolution. The next thing to ask too is, do you plan on using log compaction at all? Because if the answer is yes, then a UUID would probably not be the perfect solution for your key value. And I think, Ivan, you'd mentioned this to me earlier, right? That using a UUID for log compaction can result in some pretty serious issues.
Yeah, if you're using the UID for as a key partitioner, you're just gonna generate new keys. The compaction won't ever happen. I mean, you're not gonna as you mentioned, rewrite or update the state, let's say where your vessel is, the coordinates and stuff, because you're constantly gonna generate the new IDs, and that in the end puts a pressure on Kafka itself. So you at some time you'll also have to start vertically scaling your cluster. You're not gonna achieve anything with if you really need a low compaction and you're using the UIDs. You're just going to generate every single message is going to be with a new key, and you basically don't want that if you are using a low compaction. You really have to rethink how you want to really which key you want to use as a strategy to move forward.
And that makes sense, right? Because you're gonna have a total unique key value for every single, UUID that you use. Then log compaction is going to essentially just be a stream. It's not going to be very compact at all. Yeah, awesome. And if you're not planning on using log compaction, then potentially UUID might be acceptable. Awesome. Perfect. Thank you so much. And now, Ivan, I'll hand it over to you to show you how things look in lenses and some of the features we use to help out when you're determining key strategy.
Already. Okay. So moving to lenses, let's construct some use case that has happened in the past. Basically, by the way, you do see lenses, the screen I shared. Perfect. So let's pretend I'm a Kafka. Well, not pretend I'm Kafka admin, but let's pretend I'm working for some company and I have been paged by some tool that the storage of one cluster and only for some brokers is basically coming to an end. So first and foremost, it's really confusing why only a couple of brokers. So I went to the Grafana, let's say, to check what's the state of the storage. I figured out that which two brokers are causing the issue where the storage is coming to an end. And I figured out that there is one topic which is quite not just skyrocketing, but let's put it like that. For the use case, let's pretend it's this topic, position reports fast. It does say it has around 2 GB of data, but in a world scenario, it can be 20 terabytes. So if I go in as a Kafka admin, I can basically go and check what's happening with partitions, because I see it is rising, and it is rising. It has dozens of partitions, so I'm assuming the amount of data that is being pushed equally to all the partitions. So I'm kind of assuming that maybe all brokers should be reaching the end of the limit because my cluster should be balanced in theory. What for me as a Kafka admin, the possibility that I have is basically I can go to the partitions tab and I can see what's really happening. And kaboom, kaboom, something that we talked earlier. I can see a hotspotting. I can basically from the tab you see, basically you can notice how I do have 16 partitions in total, and out of these 16, only 4 of them are being to only 4 of them the data is being pushed. So I have 2 light bulbs. First one, okay, the key here, someone is using key partitioning. He's partitioning by some key, which most likely it's not the accurate one. And I can see that in the beginning, engineer used one partition maybe for a topic, and then it scaled to 16. So he heard me when I said single partition might not be the best one, but then he over exaggerated to 16, and I approved it. So I failed as a teacher there maybe, but okay, we have to somehow correct it. The storage is filling up, and I can go back to my engineer and say, hey, listen, we might have an issue with this topic. It's badly being keyed. It is causing the hotspots. We can shuffle and rebalance the cluster, but in the end, we might be, as we are reshuffling or rebalancing the cluster, we might be just shifting that partition to new broker, and then suddenly that new broker will have the issue the same as this one with the storage. And what can be then for the developers very very interesting to see. Maybe they are interested in also for me to how it is being keyed, which keys are being used, and how many keys I do have. In the end, there is no limits when it comes to the keys, but and how many keys within a topic you can have. But at some point, you'll see the degradation if you have millions and millions different keys. So I really want to maybe see as an engineer how many keys there are per partition. I know I have 4 partitions, but it might be that I have that maybe UUID is being used. So I really want to see how it is being done. And that can be fortunately done in SQL Studio. So what we have to find is how many unique keys we actually have. So we are gonna start with the function called collect unique. We can here see that we have a key MMSI,
Ivan,
but because
could we zoom in just a little bit?
to zoom in, yeah, definitely. Oops, my hotkeys are not working. Okay, you see better?
Better, yeah.
Okay, perfect. So because collect unique is going to give us back array, we have to actually get the size of the array. So we're going to use size of. What we're also going to do, we're going to group by partition to actually see the partition itself. And here we're gonna num of the keys, and we're gonna show here a partition itself. I think I did it correctly. Okay, now the query is, again, it's not a database, so it's going to take some time to go over all of the records in a topic. But what it's actually returning to us, we can shoot this to the table view, is it actually gives us per partition how many unique keys we have. If we have 20 terabytes of data, and in case we have maybe someone is using unique IDs, you can figure out pretty much a lot of stuff here. But maybe you can also drill down. Then as engineer, I can download this data here by a button, maybe share it to the engineer, and come back. When the engineer comes back, he can maybe even drill down. Maybe there is a huge disparity between partitions, and let's say a partition number 4 for some reason is having not maybe 2, but it has like hundreds of thousands of unique keys. So what developer can do is, as I said, drill down and say, hey, give me basically all of the keys, unique ones, which are in the partition number 4. So basically you can go in and then see all of the new unique keys, and then even drill down even further to see the data. Something that might be something that I found very helpful in my past experiences for the troubleshooting, and then again going back with the engineer and thinking about, okay, so certainly this is not the greatest partitioner key that you used. Let's figure out between us, what can you do to improve it, and how we can move forward to migrate stuff, so we can actually revisit the slide in the slide deck number 7, which says rethink what you're gonna do and use for your key next time, because we're gonna have a big issues again and again and again. So definitely good learning experience for everyone, and at least with SQL Studio, it makes it a little bit easier to figure it out, because I'm not sure if I would be using the console consumer and going through all of this, I would be dying. Certainly with all of the permissions I would have to put, and the key stores, God forbid. I mean, I know you must, but yeah, certainly it makes things it made things far easier for me in the past and for my engineers. So this is just basically, let's say, one example. Yeah.
It's great to see. Yeah. And ideally, we're doing all of this in dev, right? We're deciding the key partitioning scheme.
I'm very lucky. Yeah.
to do that in dev. And yeah, I'm trying to think about how I would even try to get this information without, SQL Studio here to be able to make these kinds of queries. I guess grep the actual logs and do my own store and then
It would be it would be
yeah.
a mess. It would be a mess. That the one thing that you have to do, but you really don't want to do it. And it will take your time and you're like pushing yourself to do it. And you don't have a strength to do it. While here you're just clicking and playing with SQL and everyone basically knows SQL. So yeah, it just makes your life easier.
Yeah, especially between that combination of the partition heat map too. It's incredibly easy to get an
Yes,
intuitive grasp.
absolutely. Straight out of the box. That's what I like the most. Just going and in a snap, just you in a split second, okay, this is just bad keys being used for partitioning. And then you can go with this to engineer, but you can drill down even more and not just tell him you are wrong, but tell him, hey, this might be you might using this wrongly because this key is not the perfect one and it's not perfect one because of this, and you give him a result of the query and everything. So you give him everything. He needs to just do the extra mile, nothing else. You did the biggest work for him to figuring out all of the bits. I mean, he can do that, or she can do that as well, pretty easily. But since you're already debugging and you have been paged, why not to do it yourself and debug it entirely and give everything on the table? Yeah.
Yeah, perfect explainer. If you get an internal ticket, somebody's wondering why the topic is having real low throughput. It's just a quick, hey, look at this heat map. Yeah,
Yes,
there's your problem.
yes. Imagine doing it without any UI or anything where you can't see this stuff. I mean, you can definitely see it by listing the partitions and go. There are certainly ways, um, but I've always been a visualization person, and if I can visualize something in front of me easily, it's a no-brainer. Yeah.
Exactly that. And then combined with the SQL Studio query, not only, yes, you're overloaded on partition 4, but here's all of the key values on partition 4. And then here's the occurrence of that too. Yeah,
Yeah.
super cool. Awesome. And you said it right too. Out of the box available. Key emphasis on box there as
Mm.
well. So if you like what you see in Lenses, definitely try it out yourself. Just go to lenses.io/box. We offer Kafka, Kafka Connect, Schema Registry, Elasticsearch, and that user interface you just saw there, available all in one Docker container. So just go to lenses.io/box, and you can get that full Docker run command along with your trial license. So
Yes,
great.
this one, not the earlier one. This one.
There you go. Perfect. Maybe we need to fix that URL.
It's a no. It's Fat Fingers. It's being called Fat Fingers.
Nice, nice. Like, yep, that's what it looks like there. You'll get an email with your Docker run command and license key there. Test your key scheme, figure out how it's being assigned partitions before you move into production.
Yeah.
Awesome. Perfect. I think we're good to wrap. Thank you so much, Yvonne. Really appreciate it.
Thank you.
Great. Awesome.
Thank you for having me, and thanks everyone for attending every week the webinar that we do. Please continue. We do it for you. So I believe see you next week.
See you next week. And if you have any topics you'd like us to discuss, as always, you can contact us on our community Slack channel. Much appreciated, y'all, and have a great weekend.
Enjoy your weekend, people.